Hello, welcome to the FRQ of the day. Hope you're doing good. Today we're going to start the 2006 exam. So we have looked at most of the FRQs that have ever existed on the AP stats exam. It only goes back to 1997. So anyway, so let's see if we can figure out this problem. So this one says two parents have each built a toy catapult for use in a game in an elementary school fair. To play the game, students will attempt to launch ping pong balls from the catapults so that the balls land within a 5-centimeter band. A target line will be drawn through the middle of the band as shown in the figure below. All points on the target line are equidistant from the launching location. So here's where the catapult is going to be put, and you got to shoot the ping pong ball over here somewhere, and then here is the band that they want to land it in, and there's the target line. So if the ball lands within the shaded band, the student will win a prize. So that's the goal. The ball's got to land in this 5-centimeter band. Okay, the parents have constructed two catapults according to slightly different plans. They want to test these catapults before building additional ones. Under identical conditions, the parents launch 40 ping pong balls from each catapult and measure the distance that the ball travels before landing. The distances to the nearest centimeter are graphed in the dot plots below. So there's the results for catapult A, the distances the ping pong balls went, and there's the distances for catapult B. And it says this, it says part A, comment on any similarities and any differences in the two distributions of distances traveled by the balls launched from catapult A and catapult B. Part B, if the parents want to maximize the probability of having ping pong balls land within the band, which one of the catapults, A or B, would be better to use than the other, and justify your choice. And then part C, using the catapult that you choose in part B, how many centimeters from the target line should this catapult be placed, and explain why you chose this distance. So if you want to pause the video and give this a shot, that would be great. Okay, so this one, first of all, it's asked us to comment on any similarities and any differences. And so we will cuss. We will, using comparative phrases, since we have two distributions, and so we will compare their centers, their unusual values, their shapes, and their spreads. And so here we go. There's kind of different ways you can word this. But in looking at this, I would say B's center is a little bit higher than A's. A certainly is more spread out, has more variability. A appears to have a couple of outliers, and their shapes are roughly both mound-shaped and symmetrical. And so this is the way I would describe this. Catapult B has a higher center with a median of around 138 centimeters than Catapult A, which has a median of about 136. And you can calculate the median because each one of these has 40 dots in it, and so the median is going to be halfway in between. It's going to have 20 dots on the left and 20 dots on the right. And if you count over here, for A, you would get that the median, the 20th and the 21st dot occur here at 136. And then for Catapult B, the 20th and the 21st dot occurs here at 138, right, in that one. So you can actually, you didn't have to calculate the medians, but you had to comment on their centers, okay? A has much more variability with a range of about 25 centimeters, while B has around 11. You didn't have to come up with those numbers. You just had to say that B appears to have a higher center and A has more variability because it's more spread out. Both graphs are roughly mound-shaped and symmetrical. So they're commented on their shapes. And then A appears to have outliers and B appears to not have outliers. And there you go. So that's what you needed to comment on there. So if you want to maximize the probability of having ping pong balls land within the band, which one should you pick? And you should pick B. And A is more spread out. And so even if you put the band like right in the middle for A, B is going to, and you put it right here in the middle for B, all right, so B is going to capture more balls there. And so that's what I said. So B would be a better choice as it has less variability. If the target line is wisely placed, B would have a higher proportion of ping pong balls land within the band than A. There you go. And whenever you're asked to compare two things, make sure you talk about both of them and compare them. Don't just say, hey, B is really good. You have to say B is better than A because, in this case, it has less variability. And then lastly, at what distance, how many centimeters from the target line should the catapult be placed. And the thing about it is, okay, and it's 5 centimeters wide, so if you put it right here at the median at 138, and it goes 2.5, goes 2.5 this way, and then it goes 2.5 this way. Well, that's going to capture all but these 10. So it would capture 30, and that would be the maximize. I mean, if you put it at 139, it would be slightly less than that. If you put it at 137, it'd be slightly less than that. So 138 would be the best place to put it. So catapult B should be placed at 138 centimeters from the target line. In the sample of 40 balls, it would capture 30 to 40 balls for 75% success. This would be the maximum percent of balls landing in the band relative to any other distance. And that's it. That's how you do the 2006 number 1. So, and if you have any questions about that, please send them to me, or questions about anything else. I look forward to hearing from you, and I look forward to seeing you again sometime soon.